This is example 4 in section 6.3. The rate of change of the number of coyotes in a population is directly proportional to 650 minus n of t, where t is the time of years, and you can read the rest of it. We have this equation then, dn dt is equal to 650 minus n times some k. That is what this sentence is saying. We're talking about the rate of change, so we're talking about a derivative of our function proportional, so that's why we have the k in there, equal to this. There is a way we could shorten this problem, but if I don't exactly know how to interpret that, then this gives us an equation we can start off with directly from that. We don't want to have the derivative in there, which means that we will move different variables to the other sides. On the left, we're going to put all of the n's. And on the right, we'll put everything in terms of t. Now, k is just a constant, which means we'll put it on the t side for now. If we integrate both sides, the integral of the left is the natural log of 650 minus n, and it's negative because if we did the u substitution, u would be equal to 650 minus n, du then would be equal to negative n dn. So we have the negative in there to make that work. The right side, we're integrating with respect to t, and because k is just a constant, that's going to become kt plus c. Next, we can divide by negative just to clean it up a little bit. We could call this minus c, which is still just a constant, so why not keep it just plus c in there then? And at this point, we want to get the function solved for n, which means we're going to take e to the power on both sides. On the left, we have e to the ln of 650 minus n. And addressing this absolute value at this point, we don't have to worry about that because the coyotes population is going down. We can read that from the original problem. I know that all the n values are less than 650. The natural log of a positive number is possible, so we don't need that. The left side is just going to become 650 minus n. On the right side, it is e to the negative kt plus c. This plus c in the exponent, we've seen enough of these problems. We know that we can just kick that out front. And then cleaning it up a little bit to solve it for n, we would get n equals 650 plus ce to the negative kt. That would be subtracting 650 from both sides, dividing by a negative, and now we have this equation. With this yellow highlighted area, we're able to get the standard equation. Now we can look at this part that I'm highlighting in green, and if we plug that in, when t equals 0, the population is 300, so 300 equals 650 plus ce to the negative k times 0, which means this is to the 0, e to the 0 is 1, and if you do just a little bit of algebra on that, you get c equals negative 350, which is good. Now, when t equals 2, the population has increased to 500. We can use that information. N equals 650 plus, actually, well, minus 350 e to the negative kt. Plug that in. So 500 goes in for n. To e to the negative k times t equals 2, plug that in, subtract 650, divide by negative 350, get 3/7 equals e to the negative 2k. That's just simplifying it a little bit. Stuck in this form so we can convert to natural logs or take the natural log of both sides. Ends up doing the same thing for you. Natural log of 3/7 equals negative 2k. Divide both sides by negative 2 or multiply by negative 1/2, and we get that k is equal to negative 1/2 times the natural log of 3/7, and then I would store that in your calculator as k. We have everything we need to know about this equation, putting all of this stuff together, and the number of coyotes is equal to 650, we found that out very early, minus 350, we figured that out from our initial condition, e to negative 2, and then that stored value of k that you have in your calculator. we're supposed to figure out the population when t equals 3. So plug 3 in for, oops, it's not a -2, that should be a t. Plug that 3 in for t and evaluate that, and you should be getting about 552. We're talking about coyotes, so you're going to want to round that to the nearest integer. You're not going to have a portion of a coyote. Give us the answer of 552. And if you look at this graph that was provided, it seemed when t equals 3, 552 seems pretty accurate with that.